Hey, you guys, this is Geometry Module 3, Topic 1, Lesson 3. We're talking about different theorems or shortcuts that we can use, what we get from knowing that two triangles are congruent. If you haven't yet, go back and watch the shorts on triangle similarity or on angle bisector proportional side theorem or on triangle proportionality theorem, because that is what we're going to talk about in the upcoming series of videos from Lesson 3. Have a highlighter, have something to write with, pens, pencils, etc. And let's get into it. We're going to talk first about the learning goals for the next section of videos is about proving the proportional side theorem. Proving comes back into it. It is geometry and logic is at the root of what we need to do. Prove the triangle proportionality theorem, so that one. And then also it's converse. And by the way, converse means that you take the theorem and you switch the order that you say things in it. And we also get, because of the way it works, a true statement. Only in this case, or some cases. Prove the proportional segments theorem associated with parallel lines, which is kind of actually what's going on over here, that when you have parallel lines and then you make triangles or angles in those parallel lines, there's a proportionality that's being kept in the relationship of the mathematics of those sides. And then prove the triangle mid-segments theorem, which might be one of my posters and my shorts that's up there that you should take a look at. So go back and get the quick snapshot of what we're doing in this lesson, and then come back and practice the rest of the contents of the lesson. Now, let's do the review section, and I got a calculator in that I have Siri, and we're going to do some mathematics that is going to show up in these problems like all the time. Solve each proportion. X divided by 22 is equal to 10 divided by 4. To solve for x, you might think cross multiply, and that's not right, or that's not wrong, but it's doing extra work. Because x is in the numerator, if you just multiply this fraction by 22, and what you do to the left side of an equation, you have to also do equally to the right. So times 22, timesing 22. Over here, these 22s will become the top and bottom of a fraction. And if the top and bottom of a fraction are equal, that they're the same, the fraction will reduce to 1. Then we have 10 times 22 divided by 4. So the 10 is going to attribute its 0 to the 22, making it 220. Divided by 4. And because I know that 20 can be divided by 4, 220 can be divided by 4. I think it's 55, but let me just go ahead and check in a second. Hey Siri, what's 220 divided by 4?
That would be 55.
Yo, I'm right. We have the exact same scenario in question 2. Because the unknown variable is in the numerator, then instead of saying let's just cross multiply, we should just acknowledge it's a solving equations problem where we need to multiply both sides by the denominator of the variable. Multiplying both sides by 5 lets those 5s reduce to 1. In essence, they're canceled. And then over here we have 5 times 5, and then we divide by 23. 5 times 5 is 25. And then when we divide by 23, there's nothing to really make that fraction nice. So let's just leave it as 25 divided by 23. If you felt compelled, you could go to the calculator. Hey Siri, what's 25 divided by 23?
25 divided by 23 is approximately 1.0869.
Nah, you can always, 25 over 23 is so much like cleaner. There's no more decimals, and it's always, you can go find the decimals when you need to. Now over here we have 16 over 16 equals 8 over y. And a little blurry, sorry, let me go ahead and fix that right now. So when we're dividing like 16 over 16, those numbers can be reduced. And so we should reduce the 16 over 16 to what it actually is, which is 1. Now, in order for us to continue solving this equation, there is a y in the denominator of that fraction, and we want y to be equal, like standing alone on its own on one side of the equation and not the other. So in order for us to solve this equation, you could say cross multiply, but you're doing too much. Let's actually multiply both sides by y. Because, you see what I did there? Y, because y. Okay, so this y and this y, this first one that I wrote in ink will be like the numerator. It's on the top of a fraction, but the y that's on the bottom will stay on the bottom. So this side will become 8y over y. And if there's ever a top and bottom of a fraction that are the same, we will be able to reduce them to 1. So the entire right side of the equation reduces to 8. because 8 times 1 is 1. On the other side of the equation, we have to multiply by y because it's balanced, and we want to balance the equation. So there's going to be a y equals, and y equals 8. We're done. That's the last part of the answer. Put a box. Okay, number 4. We're solving for the letter p. P is divided by 10, and it's equal to the fraction 22 over 4. This looks very similar to this one. Sometimes we can cleverly rearrange the letters in a proportion, the numbers in a proportion, and still wind up with an equivalent answer. Let's go ahead and prove it. Remember, if the numerator is the unknown variable and the denominator needs to be gone, we need to get rid of it. If we multiply by the fraction 10 over 1, that's the over 1. I guess I didn't say too much in the other problems, but these are all meant to be divided by 1. 5 divided by 1, 22 divided by 1, y divided by 1. You can't just multiply fractions by a number. You're multiplying a fraction by a fraction, and this fraction is 10 over 1. That way, those 10s reduce to 1. In essence, they look like they cancel. And then on the other side of the equation, get out of here, 4, there is a 10 over 1 multiplying the 22 fourths. So 10 times 22, the 0 goes on to the 22. We're still dividing by 4 because 1 times 4 makes 4, multiplying straight across. And it's going to equal the letter P. From earlier, we figured out 22 divided by 4 is 55, so I don't even need to use the calculator to calculate it again. I'm thinking intelligently that I've already done this math. I've already established that 22 over 4 is 55. Identify the relationship between the proportions in questions 1 and 4. What did I talk about in question 1 and in question 4? I mentioned that if you swap the letters, but there's an equivalent swapping, right? Instead of going across x and 10, we're going to put them in a column like a one fraction, p and 10. They're still following a grid structure. We get the same answer. Identify the relationship between the proportions in 1 and 4. We will inevitably Inevitably. I think so. Probably wrong there. Inevitably. Sure. Have 4x equals 22 times 10. In either situation, if you do the cross multiply method, which I tried to avoid, but it is maybe more visible here for question 5, 4x will happen just like 4p will happen. 22 times 10 will happen just like 22 times 10 will happen. And because that same equivalency is happening when we multiply both sides by the denominators, we wind up with equal fractions, even though, we wind up with the same equation, even though our fractions are slightly different from each other. This has been page 471, just a heads up teaser trailer. 472 is next. Probably going to need some geometry tools to draw this one. So thank you so much for checking in on this video, and I appreciate your work today, and I hope you are sticking around to see page 472. See you in the next episode.